I was too tired to even look at the video. So we did this 1 hour stress test at the University of Houston. And after the video, I just have so much work to do. We're teaching. We have a new program. We have a new after school program for juniors for ages 14, basically middle school age to high school kids. And you can come to the after school program, which is at the Ion in Houston, and you can learn the Univah Film Engine. You can start learning industry skills so that you are prepared for the workforce. So that is taking quite a chunk of my time. But here I am at the University of Houston to basically secure the idea that we can install, on basic computers. This is really helpful because it helps us see where we are strong and where we need to improve to make sure that Univah and all of its most important features can run even on computers that are not necessarily, you know, gaming PC powerhouses. So it's all about testing the integrated graphics and just, seeing what we are doing well and where we should absolutely, definitely improve. So that's the goal. Okay, so here we are. I am in the lab, the college lab, and I have brought the Univah Film Engine with me. And what we're going to do is we're going to test a debug. So, for those of you who are not developers, debug is basically the development version of your software. It's the slowest and most unoptimized version of your software. And I like to do all of my testing on debug mode because if anything crashes, I need to know why. And also, if the performance is great on debug, then that means on release mode, it's going to be exceptional. So, first things first, I'm going to show you the specs of the computer that I'm using. Again, this is a college lab computer, so they're not going to be, very powerful gaming PCs with dedicated graphics. These are just basic library computers at the college, okay? So, what we're trying to see is how Univah performs on computers that are not necessarily meant for heavy 3D work. And if we can perform well on these kinds of computers, then that makes us even more accessible. And that's the goal of Univah, is to create a software that's accessible to just about everybody, okay? So right now, I'm just showing you the debug so that you can see this is Univah. These are the raw files. And if I launch the exe right now, it's going to fail because this is not my computer. This is not my development computer, and it does not have this DLL. And so I have to go and download the DLL. I already did, so here it is. And I'm going to copy this DLL. And you've seen us do this in the other videos with our beta testers. And all you have to do is paste it here. Where you see all the other DLLs, just paste it right there. Okay, perfect. So now it's there in debug folder. I'm going to also do the same to the release folder. So let's go to the release folder. And you see all the DLLs here for release mode. As usual, also the DLL must be placed here. All right, so we're not going to run release right now. We're going to do all of our testing on debug. So let's go ahead and open up the task manager one more time so you can see. And now we can launch Univah. Great. So you can see the debug console window there. It's compiling. And it's going to ask for a serial number. I'm going to run over to my website back end, and I'm going to generate myself a license for Univah Pro, and I'm going to enter it here. Okay, now here's the cool thing about Univah. Because we've created a very comprehensive licensing system, we have what's called hardware binding, which means basically when you buy software, you buy it on a per seat basis. And if you've already used this license on another computer, it's going to tell you, hey, your license is already activated on a different PC. Do you want to deactivate it from that PC and activate it on this PC? And just click yes. That is our way of preventing abuse of our software. That way, one person can't install Univah on 10 different computers at the same time. We have systems to prevent that. So that's what that little pop up says. It says, hey, you can only install this on one computer at a time for this specific license. So, yes. All right. So, this is Univah Pro. Right now, it's running the light theme. And as you can see, it's starting at above 140 FPS on debug mode. So that's pretty cool. All right, so this is the slowest version of Univah. This is the most unoptimized version of Univah that you're seeing right now. And this is the version that we're going to test. Okay. All right. The first thing that I'm going to do after I show you the task manager, again, bear with me. This is for testing purposes. Uh, my developers like it when I show the task manager. So they're always asking me, show the task manager when you slide the sliders, when you're editing the sliders, show the task manager. You know, so this has actually been one of the most helpful tools for me because it helps me catch memory leaks. There was a time when we had really bad memory leaks and we didn't know. But from studying the task manager, we saw that the memory just kept going up and up and up and up. And even when we deleted things, the memory was not freeing. So really bad memory leaks. That was like in 2022 though. That was many years ago. That's been solved since then. All right, so now we're going to change the theme to dark mode. And whenever you change the theme to dark mode, the software just restarts for you. So you don't have to do anything. Just be patient and it's going to restart and then it's going to change to dark mode. There we go. Alrighty. So now we are in the dark mode and we are going to start testing some features in Univah. Once again, I'm just showing the task manager for my developers out there so you can see what's going on. Okay, so let's see, what do we have? Okay, so religion is open, material editor is already there, so we don't have to add those. So those are already there. Great. We're going to add a religion item to the scene. And when you add the religion item, it comes already distributed, so that's great. So you just go to grid and you can start editing that. Okay, great. So what I want you guys to notice is the responsiveness. It's not laggy. Even though we're running the slowest version of Univah on debug mode, on a computer with basically no graphics card, no dedicated graphics card, I want you to see how smooth Univah is, even on a basic PC, okay, on a standard college computer, okay. So as we slide these sliders, you're going to see, I'm going to put the task manager side by side so that you can see how the resources are being used. So as I slide these sliders, you see immediate feedback, no lag, no stuttering, no popping. Everything is very smooth. See that? So this is what, as a developer, I do. I study the smoothness, the responsiveness, and the frames per second, because this is how we catch bottlenecks to make sure that we have good math, that we are optimizing as much as we can on the CPU side and not just only prioritizing the GPU acceleration. Of course, we have GPU acceleration, but for people that don't have very expensive GPUs, we want them to know that Univah was specifically created for people with CPUs. So essentially, we have like two versions of Univah. We have the CPU version of everything, and then we have the GPU accelerated version. So that puts us in a very unique position because not a lot of people do that. Okay. All right. Now I'm going to edit these rotation sliders, and you're going to notice that they're not updating. Well, the reason for that is because of the effect sliders. So you have to go to the bottom checkboxes and just toggle that effect rotation. If it's not on, toggle it back on, and it's going to update and refresh for you. So then now you're going to see the rotation as you slide those sliders. Okay. So what is this telling you about Univah? So far, it's telling you that you can use Univah on your standard PC to make some motion graphics effects. This destroys the myth that rReligionVFX is GPU based only. It's not only for the GPU, it's also optimized primarily for the CPU. Of course, you can change distribution types very easily. You can reset. So Univah is very non-destructive. Yeah, that's awesome. And what I'm doing now is just trying to see at what point do the frames per second drop below 60? How many instances does it take when running Univah on a computer that does not have a dedicated graphics card? At what point does it start to drop below 60? And if it's at 40 instances, then so be it. That's great, actually. That's really great. Because remember, if you've watched our other videos where we show you the difference between running religion on CPU only versus turning on GPU acceleration, which is the tiny little checkbox above that says use GPU. So, of course, you guys, if you've seen those videos, you already know that running this on the GPU is much faster and you get much more, basically unlimited potential, depending on how many GPUs you have, how powerful they are, how much VRAM you have. So, yeah, you can easily create millions of instances and the FPS will stay far above 60 when running on dedicated GPUs. But we already know that, right? So you've seen us do so many live beta testing videos where we've shown you Univah installed on so many different types of dedicated GPU computers. So there's no need to reiterate that. Now, what we're trying to do is something that's very overlooked in the industry, which is making sure that your software isn't so powerful that you forget about the little guys. So, like, quite frankly, I don't think Unreal Engine could do what we're doing right now. And that's the difference between us and a lot of companies is I don't think Unreal Engine would even launch on this computer. So, you have a lot of softwares out there that are just so incredibly huge that and so unoptimized that to even launch the software, you would need like a RTX 4050 or 60, 5090 just to even launch the software. So you would need like at least 8 gig VRAM to even launch the software. So that's what we're trying to avoid. We don't want to create a system like that that is so unoptimized that someone with a regular computer can't even download and install Univah or even launch it unless they have a dedicated GPU. That's what we are testing against. We want to make sure that we are not that kind of software. Okay. So right now I'm just testing all the features, the features that you would typically use, like PBR. Everything that matters in terms of look development should work. And we, of course, we have some GPU only features, some dedicated. Those are the pro features. Those are the features that are, quite frankly, they're just too advanced for you to expect them to work on a basic computer. And we'll go over those features later. We're going to be 100% transparent with you in this video so that if you have a regular computer that is not a gaming PC, you know what to expect when you buy Univah so that you're not like blindsided. Okay. So we're going to show you the features that should work, will work, even if you don't have a dedicated GPU. And then we're going to go over the features that absolutely will not work because they're too sophisticated, they're too powerful. They do absolutely require a dedicated GPU. Okay. So as you can see right now, we're running our custom physics system and we wrote our own physics from scratch. So Univah has two types of physics. We have our custom physics, which is what you see here. We call it quick physics. We wrote this from scratch to be a fun way to get started with physics without having to learn anything complicated. And it's very optimized, very lightweight. We wrote it really for Religion VFX so that you could play with religion and do some cool effects quickly without having to um, use a middleware or go through a middleman like physics, NVIDIA physics, or bullet physics, which is what most companies do. So most companies like Maya, Autodesk Maya, Cinema 4D. When you're using Cinema 4D and you do a MoGraph effect and you want to make it dynamic, you would typically go to like bullet physics. So they use the middleman, like middleware, bullet physics. Same thing with Maya. If you're doing a mesh effect and you want to make it dynamic, you would typically have to go through bullet physics or something like that to make it dynamic. But in Univah, because we wrote our own physics from scratch, um, you know, it's just so lightweight. We avoided the bloat of adding another library and going through middleman, and so we just wrote it from scratch ourselves. And so that's why it's so incredibly like easy. It's so smooth. Pay attention to the frames per second as we're applying physics. You can see that it's not tanking the FPS, which is typically what you would see in Maya. In Maya, uh, good luck adding physics to your mesh network distribution. Excuse me, because it's not going to be this fluid. You don't get this behavior, what you're seeing right now. You don't get this in the MASH network. In Autodesk Maya MASH network, once you make your MASH network dynamic via bullet physics, it's so slow. I mean, the FPS now, they don't expose their FPS in real time like we do. A lot of companies are nervous doing that because they're afraid that their performance isn't good enough for them to publicize their FPS like we do. But we let you see the FPS. We don't hide it because again, it forces us as the developers to make sure that it's good. If it's excellent, then we know we're not going to want to hide it. So we put ourselves in a position to make sure we're excellent so that we don't have to hide things from you. Okay. So we're really the only company that I know of that just puts the FPS out there, you know? So, yeah. So as you can see, right now I'm using probably a feature. I don't think you guys have seen us use this yet, but this is the deformers, and we have several of them. And typically, how you want to do this is you would want to actually go to the cube parameters and add more subdivisions. So before you can actually really bend your objects, if you want to bend your primitives, if you want a nice smooth bend, you need to add more subdivisions. So the reason why you're seeing it bend in such a um, cubical way is because there I literally didn't add any. I haven't added enough subdivisions to this cube to be bending it. So yeah, it's gonna bend in a weird way. It's not gonna be a nice smooth bend. So just keep that in mind. You want to go to attribute editor, go to cube parameters, add more subdivisions, and then add a bend deformer. Okay. But the key here is that after adding a bend deformer, you can see that I can distribute that bend effect to all the cubes, to all the instances, and the FPS is still, very reasonable, very responsive. And adding deformers, sometimes, depending on the software, it can really tank your performance. But as you can see, you're getting a very smooth, uh, you're able to edit and see instant feedback. And when we edit the distribution, you can see that all the cubes have that bend deformation. So we're deforming all the cubes, uh, and everything is responding instantly. So that's pretty darn cool. And then on top of that, we have physics applied to this. So not only do we have a deformer active, but we have physics applied to all the instances. And then on top of that, we're editing the instances live. And the performance is so responsive, like the FPS is so good. So that's pretty darn cool. And all of this is happening without a dedicated GPU. We're doing this on debug mode. Keep this in mind, guys, please. We're using the slowest version of Univah right now. Okay, debug is always the slowest version of a software. So we're testing this intentionally on the slowest version of Univah so that if anything crashes or if anything is wrong, we can catch it and I can take a look at the console window and I don't edit any crashes out. I want you to see the problems if there's a problem. I'm not going to hide it from you. So, um, yeah. So debug mode is like nobody really, most developers would be too nervous or too scared to show you their debug mode because it's most of the time so slow you can't even work in it, you know. But we show you our debug mode so that, we're taking you behind the scenes of Univah. This is the behind the scenes. This is the development version of Univah. Okay. And then later we're going to run the release version. Okay. All right. So here's another thing too with the lights. Now, the lights, what you should know is that we are going to work on the lights in a very specific way. I don't want to give it away right now, but there are some very specific optimizations that we have to do to the lights for real-time rendering that we have not yet done because of the fact that we are working on other things before we do that for the lights. So right now, what you're seeing is that the lights are active, but you're not seeing any shadows for those lights. Okay. So that's what we're showing you. And we're just adding more. And the reason, let me explain why you didn't see any shadows for the lights. You didn't see any shadows for the lights because this computer has no dedicated graphics card. Okay. So because of the way that we've done the shadows, it you would need a dedicated GPU to see the shadows. Okay. Um, so it's a very sophisticated shadowing system. Each light has different types of shadows. So that's why you didn't see the shadows on this computer setup. Okay. So interestingly enough, I don't know. I'm surprised, to be honest, that the ocean is even working. I did not expect it to work. So this is shocking to me. I'm pleasantly surprised that the ocean system is even working. I thought that it would not. So that's interesting. So that's why I'm checking the FPS and I'm checking the task manager to see how it's performing, how much resources it's taking up. But it's surprisingly working. Uh, yeah, and I'm even able to edit. I'm able to use the parameters, which again is shocking to me because, quite frankly, I expected this to only work on computers with a dedicated graphics card. So this is a nice surprise. This is a really nice surprise. Okay, so that's cool. That's very cool. Um, and again, like we said in the other videos, this is just a starting point for what we're going to do with our water. We're going to have very, very realistic water. But while we're developing the realistic water, we wanted to at least give you something so that you can at least start playing with the water that we do have right now. Okay. So we believe in giving you something while we work on improving it so that it's film quality water. Okay. So that means it's going to have, it's going to have shoreline detection. It's going to have bubbles. It's going to have splashes. It's going to have buoyancy. It's going to have all the things that you expect from high quality water. Okay. All right. So here we are back in Religion doing a cube or grid distribution. And now we're going to take it a step further by adding one effector. So we've added the random effector. And as you can see with the random effector, you can enable it or disable it by simply clicking that little checkbox. So that's really neat. And yeah, so that's really cool that you can just do that. And you can slide these little sliders. And this is really good. We can also, of course, use all of these effects. Yes. Okay. Now we can also connect the fall off to the random by simply clicking that checkbox. And now we have a fall off effector connected to the random. So now we have two effectors. And of course, you guys have probably seen us do this so many times by this point. So you should be a pro at making this effect in Univah. It's so easy. We're going to make a quick little animation and we're going to add another keyframe there. We're going to add our start and end markers and we're going to now loop this animation. Now here's a little cheat code in Univah. In Univah, to make the animation play faster, to improve your FPS during playback, it is advised that you do not show the timeline. So you're going to notice that when the timeline is shown as it is right now, sometimes your FPS might tank. But if you just click on the library and hide the timeline, your FPS jumps right back up. So that's a little cheat code right there for Univah. Uh, if you're doing a lot of animation playback, please take a look at your FPS. That's why we put it up there. So if you're like, what the heck? Why is my animation playing so slowly? Why has my FPS tanked? All you have to do is just go to your timeline and do not show it. Just click on the library or literally just click X. Don't show the timeline and use the play button up top. So we've thought about all this, okay? That's why we have a global play button up top. So you don't have to rely on the play button on the timeline itself, okay? Now, what you see us doing right here, which is editing. You see how we're able to edit the distribution after the fact? This is what makes Univah so exciting. So after you've made a keyframe animation, you're not stuck with that distribution. You can now change things on the fly after the fact. This is so incredibly awesome for anyone who's like a technical director, film director, anyone that does any sort of directorial work or look development to be able to change things on the fly after the fact. So you're not stuck to something just because you animated it and set keyframes. That's the best thing about Univah, to be honest with you. This is one of the features that I was like, we have to have this in Univah. This is called live editing. That's what we call it. And it's just basically the ability to change your mind after you've set a keyframe. So once you've set a keyframe, you can go back and change the position of things. You can, I mean, it's just incredible. So I really love this feature about Univah, and you will too. Okay, you will too. So as you can see, I'm able to do all of this while the animation is playing. We've already set those keyframes, and now we're just changing the distribution. We're just changing the objects and its position spacing. And we can even change the distribution type. You see, it doesn't affect the animation keyframe. We can just change the distribution type because we've done such a good job of, you know, doing a clear separation of concerns, making sure that what we do in one area doesn't really affect. It's just so non-destructive is what we're saying, right? So just because we're changing the distribution type or changing the transform, as you can see, I'm changing the transform. I've changed the distribution type to spherical. I'm now changing and editing the transform. And it's non-destructive because the keyframe, the original keyframe animation we set for the fall off is still happening. It's still happening no matter what we do. Nothing is destroyed. So that's that's the best thing about this software. It's so incredibly modular. We've created like pretty much the most modular software ever. It's so modular, it's not even funny. Okay. So no matter what we do, we're not destroying that keyframe animation. We don't even have to worry about it. As long as we've got the global play button up top, we can do whatever we want to these objects. And that's pretty darn cool. So look at what we're able to do on a computer, on a basic lab computer. This is one of the computers at the Houston Community College. Okay, basic computer at the Houston Community College library. Okay, those computers at the library, they're not set up for this. Those computers are basic computers. Really, you're supposed to use them for like Microsoft Word or Excel or to make a PowerPoint. That's really what they're for. So to be able to launch a high-end computer graphics animation software and motion graphics and visual effects software on those computers, which are basically meant for Microsoft Word, that's pretty darn cool. Okay, because we're creating a pretty sophisticated animation right now, pretty sophisticated effect, and we didn't have to buy a $50,000 custom rig to do it. So that's really one of the hidden gems, one of the hidden value propositions of Univah is its accessibility. Okay, so that's pretty darn cool. Pretty darn cool. Love it. Love that for us. Yes. Okay, so let's do a new. I think this is where I show you what cannot be done on integrated or shared RAM. So we have some premium features which really require a dedicated GPU. This is one of them. So this is sign distance field. And I've added only two primitives, and I want you to see how slow it's become. It's eating up so much of our resources. Okay, our FPS is like so low right now because this feature, even though it's going to work, and quite frankly, I'm shocked. If I'm being honest with you, I'm shocked that this is even working on a computer that doesn't have a dedicated graphics card because of the way we wrote the shaders. We wrote the shaders in such a way, like this is OpenGL 4.5. Like this is like the newest version of OpenGL. Like it would be like the equivalent of the newest version of Vulkan. So I'm really shocked that this is even working On anything that is less than a GTX 1050. So I'm really surprised right now. I did not expect this to work. But this is one of those premium features that, even though it is working, guys, as you can see, I've added only two primitives and the FPS is really low. So um, this is what I was telling you. There are some features in Univah that are so sophisticated. There's a lot of math going on. Just because we make it look simple on the front end doesn't mean it's simple on the back end. There's a lot going on with shaders. There's a lot going on with ray marching, excuse me, and a lot of shader work going on in the back. Okay, so we use a lot of compute shaders. We do a lot of, just a lot. So that's why I'm shocked that this is even working on this computer. I'm really pleasantly surprised. So okay, so that's a pleasant surprise, that sign distance field primitives worked and the operators such as Smooth Union worked. Super shocked. Uh, Even though it's super slow, it did work. Now, what absolutely will not work is the Fluu system. So if you remember, we have something called Fluu, and it's our fluid system for fluids. It's real-time fluids. This is how you make atomic bombs. This is how you would make clouds. This is how you would make smoke, gas. So you would use Fluu to do that. And so right now you see it, but as you can see, it's not really working because this is, again, a really sophisticated feature and you need a dedicated GPU in order for this to work. So you need at least an NVIDIA GTX 1050. Okay. Another one of our sophisticated features, which I just added really quickly, was our atmosphere planetary system for rendering planets. It did not work because you need a dedicated GPU. And now I'm about to add text and it's going to crash because we're using debug. So it crashed on debug, and I'm going to let you see that crash. And the reason it crashed on debug was because I forgot to compile. I made some changes to how our 3D text works, and I did those changes and I compiled it for release, but I totally forgot to compile it for debug. So release has all of our new updates and stuff, but I totally forgot to compile it for debug. So debug is running the old version of Univah, and this is release. So now I'm going to try again on release, and you'll see it's going to work perfectly. There we go. So yeah, that's typical programming stuff. A lot of times we do something and we compile it for debug, we forget to compile it for release, or vice versa. So that's what you see going on there. So, of course, volumetric clouds is not going to work on a shared RAM. So you need dedicated GPU. Fluu is not going to work. You need a dedicated GPU. So these are the premium features that I was talking about. If you try to run Fluu on a basic PC, it's not going to work, guys. Okay. So you're going to need, when you want to start doing more advanced work, you will need a dedicated GPU. Okay. All right. So thank you guys so much for watching. I have gone ahead and brought back the light theme, which I don't know why you guys are like so obsessed with dark mode. I get it. I get why you like dark mode so much, but I really actually, I like light theme. I really love light theme, but that's because I'm obsessed with SketchUp. I'm a hardcore SketchUp girl. And that's actually what we were trying to create in the beginning, is we were trying to create something like SketchUp but for film. So I love the light theme more than the dark theme, actually. So but I know that I'm in the minority because all of you are like, oh my god, we like the dark mode better and we just want dark mode forever. And I'm just like, wow, I guess I'm the only one who likes, like, me and all the SketchUp users, we love light theme. So that's perfectly fine. But yes, so this is Univah, and thank you for watching. Have a great day.